Hello everyone, let's solve Max exam Math A 2015 question 1.6. Okay, so he's given you this equation, this modular equation, and he wants the minimum of x is where and the maximum of x is where. Now there is another question of the max about this modular, but in 2016 there is a question about modular function. Okay, so this is a modular equation. The difference is that here it is 2, and in the modular function you have f of x is equal to this. Okay, so here we have a value. Now look, when you have a modular function, what I usually do is you start like this. 1 second. Here. Okay, so we are going to make a small table of what? So actually let's put it over here. Yeah. So in the first place we'll put 2x minus 1, okay, which is this part over here. And then we are going to put x minus 2, okay, which is this part over here. Okay, so now I want to know in which part these two are positive. Okay, so look, I know that, look, x has a point where when 2x minus 1 equals 0, when x equals a half, right? So I'm going to add a line over here, and this is the line of a half. Okay, a half. Okay, now before this, why did I put negative over here? Just a half. Okay, so before the half everything is smaller than a half, and then everything is bigger. Okay, now for x minus 2 equals 0, x equals 2. Okay, for x minus 2 to be 0, x needs to be equals 2. Okay, so what do we do with this? We can add another line over here. Here, so here, and we are going to call it 2. Okay, so let's see. Before the 2, when x is bigger than 2, this one over here is positive, right? Always when it is bigger than 2, this is positive. But if x is smaller than 2, it starts being negative, this one over here. Okay, and 2x minus 1, when x is smaller than a half, it's what? It is negative, and then it starts being positive, right? Okay, so I hope there's no problem with this. If you are having a problem with this, try drawing both the graphs of 2x minus 1 and x minus 2, and you can see it. Okay, so, and putting values, when x is, if you choose any x like 0, you have 2 multiplied by 0 minus 1, so it is a negative number. And over here, like if you choose 3 minus 1 is a positive number. Okay, so this is basically what we are doing. Now why is this? Because we have a modular equation, right? A modular equation. So what can we do with this? Now for the first, so we are going to work with x being bigger than 2. Okay, so when x is bigger than 2, we don't need to change this the signs, right? So we'll have plus 1. Notice that this is not a modular anymore, this is just parentheses. So x minus 2 equals 2. Okay, now we are going to find the value of x in here, but if it is smaller than 2, then it's not valid, because the values that we chose were only valid if x is bigger than 2. Okay, so 3x minus 2 minus 3, sorry, 3x minus 3 is equal to 2. So x is equal to 5 divided by 3. Now notice, 5 divided by 3, it's not bigger than 2. Okay, it's not bigger than this 2, so this is not valid. This is not valid. This is not valid. Okay? Why? Because the conditions we used. Look, when it is positive, when it is in a positive interval, you can use this one. But if it is in a negative interval, as it is a modular function, if you don't remember, you need to change the signal. Okay, so it would be, instead of 2x minus 1, it would be 1 minus 2x. Okay, so we use both of them positive. So for both of them being positives, it needs to be bigger than 2, and the value that we had is not bigger than 2, so this is not good. Okay, so let's test another one. So for the next one, let's see values of x's between a half and 2's. Okay, so between a half and 2, this first one is positive, so we can take 2x minus 1. And if you want to study the subject, it is modular function and equations. Okay, so 2x minus 1, because it's positive. Now notice, in this interval over here, which is x between a half and 2, we have that this one is positive, but this one is negative. So we need to change the signal of the second one. So instead of x minus 2, it is 2 minus x equals 2. Okay, now we are going to solve this, find the value of x, and see if it is really in our interval. Okay, so 2x minus x is x, so x is equal to 1. Okay, so notice that 1 is in our interval indeed. Okay, so this is an answer. Okay, so this is an answer. Why? Because 1 is between a half and the 2. Okay, so this is an answer. Now let's, when x is smaller than a half. Now when x is smaller than a half, it is in this space over here. Okay, so both of them are negative, so both of them are going to change the signal. So instead of 2x minus 1, it is 1 minus 2x plus the other one is x minus 2, but change the signal, so 2 minus x equals 2. Okay, and we need to find now the value of x and see if it is in this interval over here. Okay, so we have minus 2x minus x minus 3x plus 1 plus 2 equals 2, so equals 0. So we'll have that x is equal to 1 divided by 3. Okay, and this is indeed smaller than a half. Okay, a third is smaller than a half, so these are our answers. So the maximum is 1 and the minimum is a third. Okay.